Hello, everyone, and welcome back. I am Benjamin Williams, and today we're still within the infrastructure section within Boson NetSim. Today, we're going to be doing a lab on network address translation number 1. So let's go ahead and get into our objectives for this current lab right here. So, if I can highlight the correct words. Okay, there we go. So our objective, it says configure network address translation NAT on P1R1. So as we can see in the top left, P1R1 is this router right here. It says to translate the private IP address 10.30.1.6 to a public address. Use static NAT translation and dynamic NAT translation. In addition, use NAT overloading or port address translation PAT. Configure the devices in Pod 1. Pod 2 has already been configured upon the initial loading of the lab. You'll be able to ping and telnet from P1R2 to all other routers by using NAT. It says NAT is used to perform address translation between two networks, yes, which are identified as the inside network and the outside network in NAT terminology. NAT is configured on a router that has one interface connected to the inside network and another interface connected to the outside network. So yes, so we're going to be doing static NAT, dynamic NAT, and also NAT overloading or PAT in this lab. So we're going to be doing all three network address translations that can be used. Of course, PAT is the most popular because usually your ISP is going to give you one public IP address, and then they're going to convert your inside local IP address to that one public IP address that they provide for you. But it's always good to know how to do static NAT and also dynamic NAT. Dynamic NAT, of course, you have to create a pool, but we're going to get into that in this lab, I guess. That has to be in our lab instructions. And then it also says Pod 2. So all of these routers and devices over here are already configured. Pod 1 is what we're going to be doing the configuration on, and we're probably going to be doing most of our configuration on P1R1 right here. And then it says that we're going to be doing telnet from P1R2, which is P1R2, which is right here. So we're going to be doing some telnet from that device. So we've already read through all of our commands and the descriptions for this lab. And we've also reviewed the IP address information. And this type of information is always good for troubleshooting purposes, and also to have when you're just looking at your network so you can see and make sure that your IP address information for each device is correct. And also the interface and net mask is correct. So without further ado, we're going to go ahead and get into this lab. Of course, we're going to be doing all of our configuration down here at the top. And all of our configuration down here at the bottom. We're going to keep our topology in the top left, and we're going to be doing all of our lab tasks in the top right. So let's go ahead and get into our lab tasks. It says task 1, it says prepare for NAT. It says the initial configuration will assign the correct host names and IP addresses to each device. In this task, you will perform some configurations to prepare the network for NAT. The password for all routers in this lab is Cisco. Okay. So for number 1, it says, when static NAT is configured, the router will translate the private inside local addresses, yes, to an inside global address for advertisement. In this lab, you will configure P1R1 to translate addresses, leaving and entering the router to use the 172.16.1.1 as an IP address. In order for other devices on the network to send packets to the 172.16.1.0 network, the interface must be configured for the address to be advertised. On P1R1, change the loopback 0 IP address to 172.16.1.1/24. Okay, so it says on P1R1, we're on that now. It says change the loopback 0 IP address to 172.16.1.1/24. So let's give it enable. And it's asking for a password to enter into privileged exec mode. So let's type in Cisco. Let's do a configure terminal. And now we're in global configuration mode. So let's go into interface loopback 0. Let's go ahead and give the full command loopback 0. All right. We can see that it is changed it up. So let's give an IP address of loopback 0 to be 172.16.1.1, and it has a /24 net mask of 255.255.255.0. All right, and let's give a no shut. All right, so we have completed task 1. So it says on P1R1, configure RIP version 2 to route for the new network. Okay, so let's do an exit. Oops, exit. All right, and let's do a router RIP, and let's do version 2 to do RIP version 2. We don't want to broadcast everything. RIP version 2 does multicast. RIP version 1 does broadcast. It basically just broadcasts out the whole routing table. So that's the difference between RIP v1 and RIP v2. But let's go ahead and get back into the lab. Let's do a network. We want to advertise the 172.16.1.0 network. Okay, so that looks good. So it says on P1R1, ping P2R1's loopback 0 interface, which should be 172.16.2.1 to verify connectivity. The ping should be successful. Okay, so let's do a, well, we can just do a do ping 172.16.2.1. And we can see we have 5 exclamation points, which means all of our pings were successful. Okay, so we prepared for that. All right, so let's go ahead and move on to task number 2. It says configure static net. So it says in this task, you will perform some configurations to enable P1R1 to perform static net functions. Static net translates a single inside local address to a single inside global address, or a single outside local address to a single outside global address. So yes, that is correct. So it says for task number 1, it says configure P1R1 serial 00 interface as a inside net interface. Okay, so let's give an exit. All right, and let's go into interface serial 00, like it said. And it said that serial 00 should be our inside. So we're looking at P1R1, so serial 00 right here should be our inside. So let's give a IPNet inside. Take my caps lock off. Inside. All right. And it says configure P1R1's fast Ethernet 00 interface to be an outside net interface. So this interface right here is going to be our outside interface. So let's give an exit. Let's go into interface fast Ethernet 00, and let's do an IPNet outside. All right. So it says configure P1R1 to statically translate 10.30.1.6, which is P1R2 serial 00 interface, to 172.16.1.100. So let's go back to P1R1. Let's do an exit. All right, and let's do an IPNet inside. We want to do a source, and we want to do a static configuration here. And the static translation we want to make, our inside local will be 10.30.1.6, like it specified in our instructions, which is the serial 00 interface. And we want to translate that to our loopback 0 interface, which we just configured, and it has an IP address of 172.16.1.100. We want to translate that to that static IP address. So it says from P1R2, it says ping P2R1's fast Ethernet 00 interface, which is 10.100.100.2. The ping should be successful. So from P1R2, which is this router right here, we're going to ping to P2. What is it? P2R1. So this router right here. So from this router to this router. So let's go to P1R2. Let's do an enable. Get the password of Cisco. All right, and let's do a ping to 10.100.100.2. All right, and we can see our 5 exclamation points, which means our pings were successful. So it says from P1R2 telnet to P2R1's fast Ethernet 00 interface. So now instead of doing the ping, we're going to telnet to that same router. So we're telnetting from this router to this router. All right, so let's do a telnet to 10.100.100.2. All right, and we can see our user access verification, and now it's asking us for the password. So we can see from our instructions, the password is Cisco. So let's type in Cisco. And we can see now we're able to access P2R1, P2R1's interface. We're able to configure it, make changes, and do whatever we want to this device, basically. Okay, so it says for number 6, it says from the telnet session to P2R1, display the users that are currently logged in. The source IP address of the VTY session should be the statically configured, the statically translated IP address. So yes, we should see that 172.16.1.100 IP address within P2R1. So let's do an enable. Oops, let's do an enable. And let's give that password of Cisco again. And let's do a show users to see all of our logged in users. And we can see that address, that static IP address that we configured on P1R1 is being translated. So that 172.16.1.100 IP address is showing instead of our inside local IP address. So that is looking good. So 7, it says disconnect the telnet session. So let's do an exit. All right, and we can see that our telnet session is now ended. So it says on P1R1, display the NAT translation table. So let's go to P1R1 before it clears, because we know that it will clear. So let's do a do show IP NAT translations. All right. And it says, if you do not see the translation, it might have timed out. Yes. So if this is the case, refresh the NAT translation table by pinging from P1R2 to P2R1's fast Ethernet 00 interface, and then display the NAT translation table on P1R1 again. So we didn't let it clear. So we can see our inside global is that static IP address that we configured, which is 172.16.1.100. And we can see our inside local IP address is the 10.30.1.6. So everything is looking correct for task number 2. So let's go ahead and move on to task number 3. All right, it says configure dynamic NAT. So we know when we're using dynamic NAT, we're going to have to configure some type of pool of addresses because we're going to be using more than one IP address, which is rare, but an ISP, I guess you can get more than one public IP address. So task 3, it says configure dynamic NAT. It says in this task, you will perform some configurations on P1R1 to enable it to perform dynamic NAT. Dynamic NAT translates local addresses, plural, to global addresses, plural, that are allocated from a pool. Routers configured with dynamic NAT maintain a dynamic NAT translation table to keep track of which internal hosts have sent traffic to which external hosts. This table is used to ensure that return traffic from the external host can be delivered to the internal host that initiated the connection. Yes, so it has to maintain that connection, so when the traffic comes back in, it can go to the correct host, like it said, that initiated the connection. So that is all correct. So it says on P1R1, remove the static NAT statement and clear the NAT table. Okay, so on P1R1, we want to do a no IP NAT inside source static, and we did the 10.30.1.6, 172.16.1.100. So we want to clear that, and let's clear our NAT translation. So let's do a clear IP NAT. Let's do a do clear IP NAT all, I think, or IPNet translations all. Okay, so let's just do a exit. Let's do a clear IPNet translation asterisk. All right, perfect. So if we do a show IPNet translation, we shouldn't see anything because we just cleared the table and we don't. So perfect. All right. So let's move on to task number 2. It says on P1R1, create a net pool named Big Pool with a single address of 172.16.1.100. Okay. So let's go into configure terminal. And let's create a pool. So let's do IPNet pool, and it says created for the name of Big Pool, and the starting IP address will be 172.16.1.100. The end address will be 172.16.1.100. The net mask is going to be a /24, I'm guessing, or no, it's not going to be. It's going to be a net mask of all 255s. So 255.255.255.255. Right. Because we only have one IP address. All right. So it says create a standard ACL that will permit all hosts on the 10.30.1.0/24 network. Okay. So let's do a access list of 1. Let's permit the 10.30.1.0 wildcard mask of 0.0.0.255 because we have a /24. Okay, say enter there. Everything is looking correct. All right, now it says configure P1R1 to perform NAT to allow the host identified in ACL1 to access external networks and use the Big Pool IP address pool. So let's do an IPNet inside source. We want to do the source list this time instead of static because we're doing dynamic NAT. Source list of 1. We want to use the pool, and we want to use the pool named Big Pool, and we don't want to overload. So let's just do Big Pool and hit enter. So it says, which interface on P1R1 is configured as an inside interface? Well, we know earlier we configured the serial 00, which is our inside interface, as the inside NAT interface. All right, so we know it's the serial 00 for the inside NAT. And question number 6 is asking which interface on P1R1 is configured as the outside NAT interface. And we know that fast Ethernet 00 interface on P1R1, we configured that to be our outside NAT interface, okay? So it says on P1R1, or on P1R2, sorry, ping P2R1's fast Ethernet 00 interface, which is 10.100.100.2 to verify connectivity. The ping should be successful. So let's go to P1R2, and let's ping down to P2R1 again. So we can just hit the up arrow, and we can see that we got 5 exclamation points. So our pings were successful. All right, it says telnet from P1R2 to P2R1's fast Ethernet 00 interface and log in. The password is Cisco. So let's hit the up arrow again, do the telnet this time. We can see that it's asking us for the telnet password to access this device. So let's type in Cisco, and we're entered into the device now. All right, so it says from the telnet session to P2R1, display the users that are currently logged in. What does it show as the source IP address? Is this IP address the IP address of P1R2 or the translated IP address? So we know that it's going to be the translated IP address, and it should be the 10. It should be the 172.16.1.100 IP address that we configured for that pool. So let's do an enable. Let's type in Cisco as our password. Let's do show users again. And we can see that we have that address that we configured for our pool, which is 172.16.1.100. So 10 is asking us to disconnect the telnet session. So let's go ahead and do an exit to disconnect this telnet session. And it says on P1R1, display the NAT translation table. So let's go ahead and do that now so we can make sure that our IP NAT translation table is not clear. So let's do a do show IP NAT translations. Do show IP NAT translation. What am I missing? Let's do an exit. Let's do a show IP NAT translations. And something went wrong. Either we let's go back to P1R1. And let's do a up arrow. Let's do a ping. Let's go back here. Okay, so I addressed table cleared. So we can see that our inside global IP address, which is that pool that we configured, it's inside global, which is the public IP address, is 172.16.1.100, and it connected to P2R1 off of port 1541, and we can see that our inside local, which is 10.30.1.6, it connected, it sent the traffic back to that same port, which is 1541. So it says, can you identify the inside local addresses that match P1R2? And what inside global address is associated with P1R2? So we just basically answered both of those questions. Like I said, the inside global is 172.16.1.100, and the inside local is 10.30.1.6, which is that serial 00 interface off of P1R1. Okay? So we're looking good. So let's go ahead and move on to task 4. It says configure NAT overloading, or PAT. And that's usually what we see in today's networks, because ISPs are only going to give out one public IP address to preserve our IP4 address range, because we have so many internet devices nowadays. So it says in this task, you will perform some configurations on P1R1 to enable it to perform NAT overloading. During this task, you will configure P1R1 with NAT overloading, so it will allow multiple hosts in the internal networks by using a single external IP address. When all inside global addresses in a NAT pool are mapped, no other inside local host will be able to communicate on the internet. Okay? So yes, we know that. So it says on P1R1, clear the NAT translation table. Okay, so let's go to P1R1. Let's do a clear IP NAT translations asterisk. All right, and let's do a show IP NAT translations to make sure that it is cleared, and it is. So it says remove the dynamic NAT statement in the pool that it references, and it says do not remove the ACL. Okay, so let's go into global configuration mode with configure terminal. All right, so remove the dynamic NAT statement. So let's do a no IP NAT inside. We want to do the source list 1, and we want to, I think it was source list 1 that we created. Yes, source list 1. We want to do the pool, and we want to do big pool, and we want to remove that. And it also says remove the pool that it references. So let's do a no IP NAT pool, big pool. And it was 172.16. It was 172.16. Let's see what was it? 16.1.100, 1.100. And the end address is 172.16.1.100. And it had a net mask of all 255s. 255. All right, so we just removed the pool that we created. So perfect. Now it says on P1R1, ensure that the serial 00 is an inside net interface, and that the serial 0 in the fast Ethernet 00 is the IP net interface. Sorry about that. So let's do a do show run, and we can confirm that our serial 00 is our IP net inside, which it wants us to do. And if we go down, we can see that our fast Ethernet 00 is our IP net outside, which is what the lab wants us to have. So that is confirmed. So it says on P1R1, create a net statement that allows host matching ACL1 to access the internet by using the IP address of P1R1's fast Ethernet 00 interface. Okay, so let's do a tab and let's go. We're already in global configuration mode, so let's do an IP net. Inside, we want to do a list IP net source. Source list of 1, and we want to go into the interface of the fast Ethernet 00, and of course we're going to overload the fast Ethernet 00 because we're going to be using PAT. All right. So now it says from P1R2 ping to P2R1's fast Ethernet 00 interface, and it has that same IP address. So let's hit the up arrow and ping, and we can see we have our 5 successful pings. So let's hurry up and go to P1R1 and do a do show IP net translations to make sure that our translation table does not erase, and we can see that now we have the inside global address, which is the fast Ethernet 00 interface on P1R1. It is 10.100.100.1, and we confirm that just by looking at the topology right here. That is this IP address right here, and we can see our inside local IP address is 10.30.1.6. So everything is looking correct, and it says, can you identify the inside local address that matches P1R2? And we can. P1R2's address is the 10.30.1.6, and we can confirm that just by looking at our topology. P1R2 is right here. Its serial 00 interface has an IP address of 10.30.1.6, and we see that right here as well. So that is the end of this lab. Let's hit grade, and hopefully we did everything correctly. And we did. So thank you guys for watching this one, and I'll see you in the next one.